Just give me a second to adjust my screen. Okay, great. Good afternoon again, everyone. Thank you very much for taking time to join our webinar today from all over Asia. I'm Kelsey, based here in Hong Kong. I'm the education manager of VEX Robotics, supporting educators in the APAC region in implementing STEM programs and robotics competitions. I've been studying and working in the education field for over 15 years, and my experience has been mainly in teaching and learning content development, teacher training, and quality assurance. I'm very happy to be here today to share with you how K-12 classrooms can benefit from VEX Robotics. So I think we will have more participants joining us today, but we will get started. Just wanted to share with you some housekeeping information before the actual presentation. Today's webinar is being recorded. We also invite your comments and questions. So please use the chat box on your Zoom. If you have any questions, if you can think of any questions at any time, any point, just type it in there. And we will be addressing your questions in the Q&A session at the end of the webinar. And my colleagues, several of my colleagues are joining the call as well. So probably they will be able to answer some of your questions in the chat box while I'm talking as well. And here is the agenda for today's session. We will talk about why you should use educational robotics and talk a little bit about VEX Continuum and our research-based STEM curriculum. And we will be sharing with you how you can use VEX Robotics tools to programs from K-12. And we will share with you the teacher support we have provided you with. And in the end, we wanted to share with you some case studies from tool schools, hoping to provide you with like how K-12 schools integrate robotics programs into their schools. And in the end of our webinar is the Q&A session. So we'll be addressing your questions during the Q&A session. We hope you walk out today knowing educational robotics is a tool for STEM, and it is the solution, but not the challenge for you. Because a lot of people, when they hear about like education robotics, they will be very, scared, and because they haven't got any experience. We want you to know everyone can teach robotics. And we also want you, hope you walk out today knowing resources to get started. And what is education robotics? So education robotics has become increasingly integrated into primary and secondary schools across the US and many other countries in recent years. Even starting from kindergartens, a lot of schools are adopting education robotics. So from the registration survey you've provided us with, we can see that a lot of you do not have any prior experience in robotics or coding. So I wanted to start with what is education robotics, or sometimes we call it pedagogical robotics. First of all, it's a learning platform, teaches robotics and programming interactively at the same time, both robotics and programming. And it teaches the design, analysis, application, and the operation of robotics. And it's designed to be interdisciplinary. It's not simply, educational robotics is not simply a popular trend in educational technology, but has been shown through a lot of research to be effective for improving students' perceptions of STEM subjects, as well as their learning outcomes, the knowledge and skills in all STEM subjects across K-12. And educational robotics can be taught from pre-kindergarten all the way to college and adult level. And of course, this is very important. The difference between educational robotics and industrial level robotics is that's safe to use. We've complied with a lot of like different safety standards in different countries across APAC and US and Europe. So that's pretty safe to use. So why we want to teach educational robotics to students? Researchers have found a spectrum of benefits for incorporating robotics into existing school curriculum. So firstly, We want to help students understand the world. Robotics are prevalent in our everyday lives, and that prevalence is increasing. Students will be able to see them at school, in their home, on the way to school. So learning about robotics can help students understand the world they live in. And the second point I wanted to talk about is learning about jobs of the future. The world of work is changing today. Tasks change, jobs change, and technology changes. So according to the research done by the University of Oxford Department of Engineering Science in 2013, which estimates that 47% of current jobs are at risk of being lost to automation. But like millions of jobs will be destroyed. Many more jobs will be simultaneously created in the process as well. For example, there have been surging demands for various careers roles like robotics engineering, robotics engineers, data scientists, hardware engineer, UX designer, robotics technician, and more. So as educators, it is vital we respond creatively, searching for innovative solutions to prepare our students for their future. So that's the reason why I want to teach education robotics. And another point I wanted to mention here is developing computational thinking. So we want to help students develop their computational thinking. So here is the definition of computational thinking, co-developed by the International Society for Technology in Education, ISTE, and the Computer Science Teachers Association, CSTA. Computer science and robotics go hand in hand. Education robotics can be an effective tool to teach computational thinking. I'm not going into too details about those definitions. You can obviously go through the definitions on the screen yourself. It's pretty self-explanatory. Students can program their robots to perform complex tasks, both in the classroom and on competition fields. For example, when students will be learning about sequencing, being able to program a robot to do certain behaviors. They can learn about loop, conditional statements with programming sensors on the robot. So they can definitely develop their computational thinking through education robotics. I wanted to mention about two more points. Is becoming comfortable with iteration and valuing the importance of learning from failure. The process, for example, the process of assembly and disassembly and programming the robot, test or debug the robot definitely involves iteration and may encounter a lot of issues and problems. Students will be able to learn from these failures and increase self-efficacy and problem-solving skills. So that's why education robotics is very important to help them learn this kind of critical thinking and problem-solving skills. Last but not least, education robotics can teach integrated STEM education in novel ways. Education robotics is actually the best organizer for integrated STEM teaching and learning, according to research. What is the goal of STEM? The goal of STEM is to learn the knowledge of each discipline of STEM, science, technology, engineering, mathematics, and then to identify connections and patterns across all four disciplines. So finally, we want students to be able to generalize their understanding, and then they can apply their knowledge in real life and to solve like authentic problem. Robotics is definitely a wonderful tool to achieve the goal of integrated STEM, teaching everything together integratively. For example, when students, they build their robot, they can learn the engineering principles. Students will practice the engineering design process during the robot building process. They can then program their robot, and then they can learn the technology, the coding, the programming, definitely. And they can also be learning about the science, such as the scientific method when they're using, studying robotics, observation, experiment, data collection, analysis, definitely those involves science. And robotics allows for investigation of applied physics and mechanical concepts, system thinking, and of course, artificial intelligence as well. In terms of the math, educational robotics is an excellent way to make math more meaningful for students. For example, they can learn about the angle, the concept like the angle of math, or they will need to calculate the gear ratio. So as a summary, educational robotics is a very good tool, effective tool to teach integrated STEM. And I wanted to share with you a little bit about who we are, as some of you are new to this field. So VEX Robotics is an educational robotics developer of hardware, software, and curriculum that is used in classrooms all around the world. We are wholly owned by Innovation First International, founded in 1996. Actually, we are now a leader in educational and competitive robotics products, and headquartered in the US, we have 12 offices around the globe. In APAC, we have offices here in Hong Kong, in China, Shenzhen, Wuhan, and Dongguan, servicing and supporting partners, students, and teachers in APAC region. And wanted to share with you some of our global impact, which you can see from these images here. We are very proud that the VEX World Championship, that's our robotics competitions, has been recognized as the world's largest robotics competition by Guinness World Records in 2016 and 2018. In May of 2021, we were awarded as the third Guinness World Record, this time as the largest online robotics competition. Where over 1,400 teams participated, because we have started this kind of online competitions during COVID. And we're also very proud to be part of the STEM education advocacy movement in the world. You can see like Obama visited a VEX classroom in Miami, and we have also partnered with a wide number of large multinational organizations to sponsor. For example, NASA, Google, Tesla, and Asia and China, like Alibaba and Tencent. And we have contributed to the development of STEM. So our mission statement is here. We want to create tools that educators and mentors will use to shape the learners of today into the problem-solving leaders of tomorrow. I wanted to share with you our key. Our key is this VEX Continuum. So our solutions span the full continuum from pre-kindergarten through college of both formal and informal education with accessible, scalable, and affordable solutions. The VEX Continuum supports school-wide STEM learning goes through our hardware, software, and teacher support. All our educational robotics system, like what I mentioned about hardware and software, are supported with free teacher training, standards aligned curriculum, and online support resources, which I will be sharing with you in later slides. So from kindergarten to career level, we have STEM solutions for all ages. So here what you can see, we display our robotics hardware continuum, starting from this VEX 1, 2, 3 for students as young as 4. They can use this fun robot to explore basic logic and problem-solving skills. It's an introduction to computational thinking. It's the exploration of basic logic. That's the introductory level. Everyone can do it, like kindergarten students. And then students can move to VEX Go and then VEX IQ for students ages 8+ and 10+. Both platforms are considered as plastic construction systems. So students can learn the fundamental of STEM and the basics and intermediates mechatronics using this plastic construction systems. And finally, students can advance to VEX EXP, V5, and WorkCell. They are going to build their robot out of metal. So those 3 platforms are considered as metal construction systems using real-world tools and fasteners, high-tech sensors, and exploring advanced software techniques. You can definitely see the progression here from the kindergarten level all the way to the college level. This continuum of 1, 2, 3 to V5 allows students to explore STEM from pre-kindergarten all the way to university. We have talked about our continuum in hardware, and now we wanted to share with you our continuum in software. So we have also developed robotics programming software that will allow novices to learn how to code and advanced programmers to customize and lock their robotics potential as well. So here is the programming software continuum, starting from tactile programming. So programming off the screen, what we call is tactile programming. If you're not familiar with those terms in programming or robotics. So that for VEX 123 is programmable without a computer, and then can move to VEX Code block-based interface powered by Scratch. Probably a lot of you have heard Scratch block coding. So simply students can use drag and drop interface to create functioning projects to do all kinds of programming using block-based programming. And then students can move to text-based coding. Text-based coding here, we talk about Python, both Python and C++. And students that move to this text-based coding level, they can see in real time the C++ and Python code generated by each block added to their project. And then they can also convert their block-based project to a text-based project at the same time. So they can see both Python, C++, and the block-based coding. The last step you can see on this arrow, on this progression route, is the VEX Code Professional, VEX Code Pro. This interface allows students with same tools and programming languages that professional programmers, like professionals, use every day. So from this chart, this arrow, you can see VEX Code is consistent across blocks and text, like across all the different platforms from 1, 2, 3 to V5. As students progress from primary to secondary school and beyond, they don't need to learn a different kind of interface. We don't want them to spend time or waste their time to familiarize with themselves with different platforms. So all the platforms are the same, so they don't need to learn a different interface. So this is our the software continuum. The ultimate task, the excitement for many students studying the VEX STEM program, is to design, build, and code a robot to solve one of our annual robotics challenges. The winners will go on to compete against teams around the world. You can see here, the VEX family of competitions is the largest and fastest growing robotics events globally. The World Championship is presented by REC Foundation, which is a nonprofit organization. The full name is Robotics Education and Competition Foundation. So currently there are more than 27,000 teams from over 61 countries competing in over 3,000 tournaments worldwide. Just wanted to share with you some exciting moments we've captured for VEX 2022 World Championship. Actually, it's happened last week in Dallas. It's just done last week in Dallas, US. Not sure if any of you had the chance to visit the event. It's pretty exciting. The first huge project, the event after COVID. Some of the images just wanted to share with you. And these are the teams from APAC, different countries. And we always do very well in competitions for our APAC teams. Some images for VEX IQ, the primary level competitions, primary and junior secondary school, and the high school level competition, VEX VRC competition. And here you can see our competition pipeline. We provide a variety of competition platforms from preschool to university students. I'm not going to talk about each of them, just wanted to show you we have different kind of competitions from preschool all the way to a college level. We've talked about our hardware and software and also competitions. Now we wanted to move to another thing that educators care most about. That's the curriculum. VEX Continuums also applies to our STEM curriculum. Our STEM curriculum is a throughout K-12 educational robotics pedagogy. We have created this interdisciplinary STEM curriculum that we call STEM labs. Based on research and studies, our STEM curriculum has been developed by a team of former STEM teachers. The practitioners, I mean, they've been working in the field for over like 10 years. We bring together current research and classroom experience to create comprehensive teacher tools and training to ensure teachers are prepared to succeed with our technology, curriculum, and pedagogy. Wanted to show you some of our like teacher resources summary. STEM labs provide educators with free and easy to follow STEM lab lesson plans. We provide you with lesson plans, teacher support materials, integrated teacher notes, pacing guides, and even student-facing materials, student-facing PowerPoints, because a lot of time teachers spend a lot of time designing those student-facing PowerPoints or materials. All of our curricular and STEM labs are aligned with international standards, helping to meet the learning objectives for students worldwide. Especially, I know a lot of you are from international schools or like bilingual schools. You probably use British curriculum or IB or NGSS US curriculum or other curriculum. So probably some of the standards here are familiar to you, like the NGSS standard, Common Core standard, the British National Curriculum. So we've mapped all our STEM labs and curriculum to those standards that would be able to help you with planning of your robotics program. Here is an example of a pacing guide for one of our platform. What I wanted to show you here is actually our STEM lab curriculum materials are designed to be used in a variety of ways to provide teachers with options to pick and choose the teaching resources that fit your needs and your students' needs as well. Our STEM curriculum functions as plug-in lessons that can fit into schools or learning centers curriculum. It could be part of your STEM curriculum, part of your robotics or coding curriculum, or after school activities and clubs. So we have schools using our curriculum in all different kind of scenarios, and also for learning centers as well. And multiple labs can be utilized in sequential order to create a unique extended learning experience. And you can also pick and select the units that fit to your school's curriculum. We usually provide several pacing guides for each platform. For example, here, this is an example for our V5 platform pacing guide. We provided you with 6 weeks, 9 weeks, 12 weeks, and 18 weeks options that progress from beginner to intermediate levels and offers variation on like engineering focus or coding focus instruction sequences. So just wanted to share with you one example here of our pacing guide. Okay, so how we can use educational robotics, VEX robotics tools to progress from K to 12. I will talk about each of these platforms briefly and give you some examples and videos how to help students develop STEM knowledge and skills using these tools. So the first one, starting with VEX 1, 2, 3 for students ages 4 to 9. So usually we would recommend kindergarten students, and or for primary school, it would be primary 1 and primary 2 students. It's an interactive programmable robot that takes computer science and computational thinking off the screen. And why we call it coding as easy as 1, 2, 3, because we've got like 3 ways to code a VEX 1, 2, 3 robot. The first way, what I show you here, we call it tactile programming, touch and go. Students can learn sequencing by simple touch. So there are different arrows and you can program them to do sequencing, and they can learn basic logic and problem solving by controlling the movements on the robot and the sounds of the robot. They can program that to have different sounds and to move different steps. That's the first way of program. And the second way is to program the robot using coder and coder cards. So it is programmable without a computer. Using this coder and physical cards, students can learn real programming away from screen. You can see probably the image is a little bit small, but you can see the coder cards are color coded. For example, all those lines about coder cards about movements are color coded in blue. And the, for example, the if conditional statements and other statements like loop, they are color coded with orange. So it's very easy for students to locate and very easy for classroom management as well. That's the second way to code your 1, 2, 3 robot. The third way to code your 1, 2, 3 robot is to use this block-based coding. VEX code, what we call that, the software is called VEX code 1, 2, 3. It's available for tablets, Chromebooks, Mac, and Windows, and basically all devices. It allows students to program with block coding software powered by Scratch. So it's by simple drag and drop. It's very easy and user-friendly for small hands. For the 1, 2, 3 STEM labs, our STEM curriculum, we've provided you with 10 project-based units plus 30 activity lessons. Those activity lessons can be functioned as supplementary activities or extracurricular activities. And so all those units and activities are categorized into 6 subject areas: coding, science, literacy, math, social, emotional learning, and art. So students will be able to learn the knowledge and skills related to those 6 subjects. You can see for this level, VEX 1, 2, 3, this level, we've included the social emotional learning aspect because for this age group, kindergarten student, primary 1 and 2, this is a very important area for them to learn and to develop. Wanted to share with you some STEM lab examples, our lesson examples with you for 1, 2, 3. Using stories to introduce robotics to kids. We have this Meteor Robot storybook. There are a lot of comparison to real life examples to help students understand what is robotics. For example, on this page, you can see when we want to introduce eye sensor, because on this robot, 1, 2, 3 robot, we have an eye sensor on it. When we introduce the eye sensor to students, we want them to compare the eye sensor with the human eyes. For human eyes, when they open their eyes, when they see an apple, they will think about, wow, it's delicious. Wow, it is a red apple. But for a robot, the eye sensor, when a robot sees an apple, what a robot can recognize is the color. It's red, and it can recognize the distance. Well, it's like distance, how far it is to this apple. Because on this robot, we have eye sensor, and it can also detect the distance as well. So this is an example I wanted to share with you how to use stories to introduce robotics to kids, especially for this level. Probably we can, it's not only to use this 1, 2, 3 in your STEM lesson, we can also use that in other lessons, art lessons, even English lessons as well. Another example to help students develop social emotional aspect is this project, this unit, create your own emotion code. We ask students to create their own emotional code to express their feelings like excitement, angry, and gratitude. So by that way, they can learn about sequencing, the algorithm, and also social emotional. They can know how to express their feelings or how to express the feelings through this robot and programming. And an example I wanted to share with you to teach math with this 1, 2, 3 robot. We ask them to code their robot to point and drive to the smaller number. So we have this field, robotics fields for 1, 2, 3. We provide that to you and the kids and classroom bundle. And for example, we write 2 numbers there, 13 and 23, and ask students to code and drive to the smaller number. By that way, students will be able to learn the simple math for kindergarten students or even primary 1. This is just one example I wanted to share with you how to teach math with 1, 2, 3. Okay, so enough example about 1, 2, 3. We've still got a lot of very good teaching tools. Don't have time to share with you. We will talk about VEX Go for the later slides, for several more slides. So VEX Go is an affordable construction system for students ages 8 to 12. That teaches the fundamentals of STEM through fun, hands-on activities that help primary school students perceive coding and engineering in a fun and positive way. So the VEX Go, this platform is for primary students. And how we recommend you to teach STEM with VEX Go. We recommend you with 3 steps. Build it. The first step would be build it, to ask students to design and build their robot using this classic construction system. And the second way is power it. The second step, power it, they can add the motor and battery to it and learn about force. And the third step would be coded. So students can add the brain and sensors to it, and then they can code it. So through the 3 ways, we can definitely see a scaffolded progression here. And another feature probably you can aware from this image that makes VEX Go an easy building system is the parts have their own unique color. These colors help students match the parts to the steps in the build instructions, and color-coded parts are also easy for classroom management as well for teachers. And wanted to share with you some examples here about build it, power and code it. So for example, this one, build it. This is a robot arm we ask students to build. Students can design and build this robotics arm. Of course, at the very beginning, we provide them with the build instructions, step-by-step, easy to navigate build instructions for them to follow. And after several times, several lessons, they can design their own robotics arm, design and build their own arms as well. And through this process, they can learn about the engineering concept and even the math behind. For example, they can learn the math behind the arms angles. So this is an example about build it. And another example is power it. That's the second step for this robotics arm. And actually students can build different kind of builds, robots using VEX Go. What I wanted to share you with just one example here is the robot arm. So what does it mean by motorize, power it? So you can see we add the battery and then add the switch. So they can control their robots by powering it. They can learn about the force and other concept there. And the third step I mentioned is coded. For this one, we add the robot brain and different kind of sensors, the eye sensors, electromagnet sensors here. We code this robot arm with brains and the sensors I just mentioned using our VEX Code Go software. So it's a block-based coding software, and they can program their robot arm to do different kind of behaviors. So here you can see we can teach about the industrial robotics concept. You can see here multiple robots working together mechanically and cooperatively without human intervention. So that's the simulation of industrial robot arm. So there are a lot of concepts we can teach students here using VEX Go. And about the VEX Go STEM labs, the educator resources, we provide you with 20 STEM lab units and 68 activity lessons. Those activity lessons and STEM lab units are categorized into 5 subject areas, which are actually STEAM, science, technology, and also arts. In arts, we have included lessons about art, social studies, literacy, geography, and design. Students will be learning about the knowledge and skills related to all the subjects. Just another example here about VEX Go STEM lab lessons. So this STEM lab unit is called physical science. I put it here because I wanted to share with you the progression, the learning progression. We have 5 labs in this unit. So the lab 1 is about unpowered supercar. We want students to build this unpowered supercar. And lab 2 is the supercar and with other functions. And then the lab 3, lab 4, they will need to add switch, power it. And then lab 5, they will need to add the brain and different sensors, so code it. So in each lab, we provide students with this progression, learning progression routes. Yep, so those are some of the examples I wanted to share with you about VEX Go platform. And next platform I wanted to talk about is this VEX IQ. We've just launched the 2nd generation of VEX IQ several months ago. It's a platform for students ages 10 to 14. It is also a plastic construction systems. Comparing to Go, as both platforms are like plastic, but it's a more immersive exploration of robotics, engineering, and competitions, inspiring students with a complete STEM experience. Students will also be learning about the soft skills required, problem solving, communication, time management, and so on. It can also lead to the VEX IQ competition. Students will have the chance to go to the World Championship in the US if they win the game in their local countries or areas. And we provided you with 36 weeks of STEM lab lessons for VEX IQ. Wanted to share with you several examples of VEX IQ. Each one of the examples is about, the first example is about teaching science with VEX IQ, how students can learn science through VEX IQ. This activity we provide you with in STEM lab is called Robot Tractor Pull Challenge. So in this activity, students will see how far an IQ motion beam can be pulled in 5 seconds. Based on how and where a rope from the IQ kit was attached to the robot to create an unbalanced force. So students will be learning about science during the whole process of the project. They will learn about the force, how unbalanced force created motion, and how force affects the movement of the robot. They will need to apply the information to design and build a rope attachment for the robot to pull an IQ motion beam the farthest in this challenge. This is just one example of how we can teach science with VEX IQ. And the example here I wanted to show you is how students can learn technology with IQ. So you can see an optical sensor highlighted in yellow here. That's an optical sensor. So it's similar to the color sensor. This is called optical sensor. It has been mounted at the front of the Clawbot. In this activity, this challenge, we call it I Spy Treasure activity. The robot will drive to 2 different cubes and use the optical sensor to detect the color. If the cube is green, as you can see, the robot will not collect it. And if it detects red, as you can see here, it will collect it and move it to the home zone. So students will definitely learn about the optical sensor, how it works, and learn about the programming, because the technology here will mean is programming. So the program, they would be able to collect the data. They can use data from the sensor in the code to have the robot make decisions, like how it can be used with if then and repeat blocks, those programming in a project to make their simple clawback collect the cube based on its color. I mentioned about the conditional statement and if then, those programming languages. For example, like if it detects red or other color, then it will repeat certain behaviors. So students will definitely develop their computational thinking skills while they use this kind of conditional statements and simple loops in their coding. This is an example about teaching technology with IQ. And now what I show you here, this example is to show you how students can learn engineering with IQ. So the goal of this challenge is to use the controller to drive the robot and stack as many cubes as they can within minutes. So one of the key things in this challenge is the robot arm. You can see it has the claw and also the robot arm. That's the key thing. Student will learn about robotics arm, what robotics arms are, and the elements of a robot arm, and how different arm mechanism work, and what makes an effective arm design. Then students will apply their learning to stack as many cubes as they can in the stack up challenge. So in this process, students will learn about the design, the building, and iterating of their arm designs. Definitely the engineering design process. I will show you several like different kind of arms design. You don't need to know, remember all the names, but I just wanted to give you some examples. We have double reverse arm, 4-bar arm, and swing arm, and 4-bar arm. And each of the design has its own like advantages and disadvantages. All of those can be taught in VEX IQ or even like V5 or Go. So those are definitely design concepts and the mechanism. So those are some of the examples I wanted to share with you about teaching engineering. And the last example I wanted to share with you about VEX IQ is teaching math. How we can teach math. Of course, it's very like self-explanatory here. You can calculate the pitch and calculate like the gear ratios. While during the process, students will learn about math. I'm not going into too details for this one. And the last platform I wanted to share with you on our VEX Continuum is this V5 family for students ages 14 to 18 plus. It represents our 5th generation of education robotics system developed with 20 years of experience. So this V5 electronics, like this family, they use similar sensors. They use state-of-the-art technology to ensure relevant educational outcomes. And the mechanical system, the V5 education mechanical systems include versatile elements that makes engineering approachable for new students while still providing experienced users with endless design possibilities. So this EXP, we have like different aims and categorization for different programs. EXP is for classroom teaching and learning, and V5 is for competition, and WorkCell is for workforce preparation. For this EXP, it provides students with the real-world immersion into STEM. It's a metal construction system. It can teach the real-world design and construction, and we've provided you with 14 weeks of STEM lessons and 32 activity lessons. And there are a lot of games involved as well. In terms of the programming, the VEX EXP comes with all the electronics, the brain, the controller, different sensors, all the basic sensor like optical sensors, bumper sensors needed to power and code a robot. It actually provides students with different ability levels, a proper programming software and language. They can use block-based coding. They can use Python language coding or C++. So they can choose whatever, their levels are, or the teachers want them to learn. So they can code with either Block, Python, or C++. That's for EXP. And for V5, as I mentioned, it's a competition-focused robot system. It's also a metal construction system, just like EXP. And competition environment requires more powerful motors and additional ports. So we have a touch screen for V5. To like operation away from a computer, and longer metal structural parts for larger robots. So comparing to EXP, it has like larger structural parts, for some of the metal parts. And the most exciting thing about this V5 it's leads to VRC, the VEX Robotics competition, our world championship. Students, they will have the chance to go to the world championship if they win locally. And we've provided students and teachers with 18 weeks of STEM lab lessons and 6 VRC virtual skills lessons. So the VRC, the virtual skills lessons, are virtual competition materials for students, so they can practice the skills about the competition using virtual robots. Now going to share with this one. And the last platform, and the last platform in this V5 family is the WorkCell. So WorkCell is an introduction into the world of industrial robotics. It is a platform actually bridges the gap between the classroom and workforce. WorkCell is a robotic arm, conveyor, and sensor construction system for vocational education in industrial robotics and automation systems. It teaches best practices as well as safety precautions to keep workers safe. And you can see from these images, there are a lot of things students can gain from the WorkCell. For example, they can gain the manufacturing workforce readiness. They will be able to do a lot of hands-on technical skills. They will develop those hands-on technical skills, and they will be learning about the problem solving and collaboration skills as well. We've also provided you with 12 weeks of lessons. What I wanted to share with you here is how WorkCell can bridge the gap between classroom and industrial level robots. We have 2 videos here. One on the left is the factory robotics in the workplace. So in this video, on the left, you can see it's a real life 5-axis robotic arm for automatic palletizing, packaging, and sorting in manufactories. Comparing with the VEX WorkCell, it's more complex, but the basic principle is the same. Sensors are used for detection, and robotic arms are used for sorting and stacking, as probably can see from the video. And on the right is the video for the WorkCell, the factory robotics in the classroom. So in order to teach students about industrial robotics in vocational education, what we have done is we have created this really cost-effective industrial level robotics model that can be used in the classroom. You can see it's very small. It's not small enough to be placed on the classroom desk, the table, and makes this very accessible. And we can see in this video, the robotic arm is imitating the industrial robotic arm to perform a color-based sorting and palletizing. It has a 5-axis robotic arm as well. So we have a lot of different points of movement here, and we can also extend, can move from side to side and pick things up and down. So this is simply a simulation of the industrial level robot arms. And you can also see for the arm tooling, we can change the arm tooling as well. For example, on the left video, we've added the electromagnet for the arm tooling for picking up and placing disc. And on the right, at the end of the arm tooling, we have a pen. So it can draw pictures or draw lines using this pen, a marker attachment to that. This is just a simple example to share with you how we can bridge the gap between classroom and industrial level robotics. Okay. And I've talked about all our platform, the hardware platform, and those physical robot platform. The last platform I wanted to share with you is this computer science VEX called VR platform. Especially during COVID, it's sometimes very difficult to learn with physical robot. Students can continue their learning away from their robots using this VEX called VR. This is completely online and browser-based platform, allows students to learn computer science and robotics at home. And they can complete different kind of activities and using this programming software and using this virtual playgrounds and virtual robots. For example, you can see from the animation here, we have this virtual robot with the basic sensors, similar sensors with physical robots, and we provide a different kind of the virtual playground for students to do different kind of activities to help them with their STEM learning. And also on the top, we can see the live dashboard, the data recorded by the sensors. We've also provided you with the free student-facing materials as well, and also teacher materials, the computer science block course and Python course. Yeah, so I've talked about all our system, the hardware, the software, our standard-aligned research-based curriculum, and our competitions. And now I wanted to share with you a little bit about our teacher support and professional development. So this is the VEX Professional Development online certification course. We offer free and self-paced training that helps educators at all different ability levels for our platforms. So if you want to know more, you can go to the certification.vex.com. You will be able to find all the certification course there. After the learning of each course, you will be able to know how to navigate all our resources and how to get started. So this is completely free and at your own pace. And we also have this PD Plus platform, Professional Development Plus. It's a community learning platform that enables educators to learn from and interact with experts in classroom and competitive robots. So members of VEX PD Plus have a network of resources and receive year-round coaching and feedback from experts. What's more exciting, we've got this educator conference every year. You will be able to meet all the robotics STEM educators around the world at the World Championship. The first year of the annual educator conference just happened last week in Dallas, so it's pretty exciting. Hope you will have this chance to join the competition next year. The competition, also the educator conference next year in the US. The other teacher training or professional development support we've got is VEX Academy. That's the the official training organization under VEX Robotics, established in 2016. We have got 27 centers nowadays, and we provide teacher training and robotics and computer science course for students and also for K-12 schools. So if you want to have like customized teacher training, because what we mentioned before about the certification course, online certification course, and PD Plus, those are standardized course. If you want to have customized training course for your school, so just let us know. We will be able to provide you with customized teacher training as well. And this STEM library, just probably one word, it's a resource of over 700 articles about educational robotics. You'll be able to find all your answers in our STEM library. At last, I wanted to share with you two cases, like how K-12 schools integrate robotics programs in their school. So one case, one sharing is from an international school, using British curriculum in Thailand, and the other example is an international school based in China. This one, I'm going to share with you the first case, that's Stanley British School. The tech director presented.
Hello, my name is Mel
program.
Hall, and I'm head of EdTech here at DBS, Stanley British
Oh, just a second.
School. DBS is a growing 4-year-old British international school close to Bangkok, Thailand. We have strong ambition, and our motto, always striving for greater things, guides everything we do. My story is about developing a robotics program for prep school students using VEX IQ. We started in order to improve our computing curriculum. Little did we know that 2 years later, we would end up winning trophies at the World Championships. We had a few small robots and some iPad apps, but wanted to give our students a chance to design, build, and program something significant. After research, we settled on the VEX IQ robotics program as it offered quality resources, online CPD, STEM lab learning resources, and a chance to enter local competitions. In addition to integrating robotics into our standard curriculum, we also went in at the deep end, running a robotics club for competition with students who'd expressed an interest. Our students literally opened the boxes of new equipment on the first day of our VEX Robotics CCA club. Staff and students were all at square one together, embarking on the same learning curve, possibly a unique pedagogical experience anywhere in the world. An incredible learning experience ensued as students and staff learned together. It is the story of our team that I will speak about today. Students cannot truly learn about robotics by reading about robotics. Watching a video may teach a little more, but there is no substitute for the hands-on experience of actually building a robot. Coupled with the teamwork challenge skills needed to prepare for intense competition, this project has been like no other. During the VEX IQ challenge, teams of students design and build a robot to play with other teams in a game-based engineering challenge. Their STEM concepts were certainly put to the test, alongside learning lifelong skills in digital responsibility, teamwork, leadership, communication, and so much more. The VEX IQ Robotics Championships prides itself on being student-led but coach-supported, a fairly unique experience for our students. They are the driving force behind their progress, with adults guiding decisions and supporting them. Our teams naturally subdivided into roles suiting their experience, and they cooperatively planned their time. Our coaches supported their STEM knowledge, such as teaching impromptu masterclasses on 4-bar linkage design. So unique, much of their previous experience had been with a teacher pedagogical approach. 2 years ago, we taught with some nice PowerPoints and some informative YouTube videos. We had some basic floor robots to teach about instructions and block-based coding to teach about algorithms and to complete on-screen challenges. Since the introduction of VEX Robotics, our learning has transformed and our makerspace has come alive. Robotics team students engage in strategic decisions with each other, offering design solutions and problems, such as the lifting arm is not strong enough. Our coaches can then spot this as a teaching opportunity with returned questions such as, well, how can we use gears to change the torque? They design and build robots to complete challenges using motors and sensors, gears and levers, moving them with controllers, or writing code. One of the really nice aspects of the project was that our coaches learned at exactly the same time as our students. Ideas have come from both sides as to how to solve problems. Head-scratching moments have been shared by both parties, often leading to after-hours research and learning, using technology to communicate and collaborate ideas well after the end of the school day, once everyone has gone home. We have already developed our VEX Robotics program to include our younger students, as we were the first school in Thailand to run a robotics club with the less complex VEX Go equipment. We are currently building a new senior school building and will incorporate the more complex VEX V5 robotics into a purpose-built lab where we will continue to develop the robotics curriculum and enter teams into the Thailand national competition at the high school level.
Yeah, this is the first case study I wanted to share with you. We are very happy to help schools and to help students at their schools to learn about all the STEM knowledge and skills, and also help them develop all the soft skills. And actually, there are a lot more schools like this. We hope to collect all the case studies, and we will be able to share with you their experiences in implementing the robotics program in their school. The second example I wanted to share with you is this school. It's called Wuhan Yangtze International School, YWIS, based in China. They've started with our VEX IQ and VEX V5 programs in 2017. And now they have started implementing VEX 1, 2, 3, and Go for younger year students. So for their kindergarten and elementary school level, they've got one robotics class per week using 1, 2, 3, and Go. For their middle school and high school, they've got about like 2 robotics classes per week using IQ and V5. And they've also joined the VEX IQ competitions and the V5 competitions before. They've got like 10 teams, altogether about like 15 teams before, and they've won a lot of like awards during the past seasons. They are very excited and involved in the VEX competitions and classroom teaching and learning. They are also our event partner. So if you want to organize competitions, like local competitions, we welcome that as well. So they used to be our like events. They were once our like event partner of VEX competitions, and they've invited a lot of international schools in China to join their competitions. Just wanted to share with you this example because a lot of times schools asking us like how many lessons we can for students you suggest for like 1 week. So we have all different kind of case studies. If you want to have some like consultancy with us, just let us know like how to, we will help you like to plan your robotics and coding programs in your school. Last, before the Q&A session, I just wanted to share with you an exciting news. Our new robotics season has just begun this week. So we will have this new season kickoff webinar next month, early next month, for the VRC, the VEX Robotics Competition new season kickoff would be 9th of June, a Thursday. And this one would be 10th of June on Friday. So we will be sharing this information with you with an email later after the session as well. Okay, so now is the Q&A session. If you've got any questions, you can just ask us. We can see a lot of like questions in the chat box, and thank you, Andy, for helping answer those questions. If you have any more questions, please type it there in the chat box or just unmute yourself and we will be able to address your questions. One question is about, do we have integration with Microsoft Make Code? Unfortunately, we don't have the integration with Microsoft Make Code. All our platforms and softwares are actually either browser-based or actually it's like app-based. It's our own platform, so we don't have the integration with Microsoft Make Code. Yes, one question is about, do the VEX IQ Gen 2 STEM labs integrate with Gen 1 equipment? Yes, we do offer like adaptation suggestions, like how you can implement Gen 2 STEM labs with Gen 1 equipment. We have provided you with suggestions and adaptation strategies on our website. I will be able to share with you both a little bit later in an email the link for the adaptation plan. Yes, you can, but of course you will need to do a little bit like adaptation because some of the parts and electronics parts like sensors are different. Mm-hmm. Yeah. Another question from Chris. Do you have examples of the challenges that students have done before in the competition so they could practice? We do have all the challenges, I mean, the rules and a lot of like materials available on our robotics website, REC website. What do you mean by like, yeah, examples of the challenges of they have done. We have provided this, what Andy shared, it's like the build instructions, the basic instructions, the build instructions suggested for you. But for students, their engineering like process, their design, we're not able to share about their, engineering notebook with you. Yeah, because it's like their own creative ideas. We're not allowed to share that. Yeah, but of course we have a standardized like the basic build instructions for you for all past events. The other one would be any idea when the Gen 1 equipment will be phased out in VIQC. That's a competition related questions. Not sure if Andy has an answer for that, like Gen 1 equipment will be phased out in VIQC.
Sorry, thank you, Bo, for asking that question. So just to follow some of our past examples to use to look forward into the future. In our past, for the VEX Robotics competition, there was a previous generation called the Cortex, and for the new generation, we called it V5. So it was about 4 years from the introduction of V5 before we saw that many people stopped using the Cortex altogether. In fact, when you look at the competition, people just found that the new version was just that much more user-friendly. There is a lot more that they could gain out of it. So we saw that there was an eventual phase out from even the competitors. So just this season is when we saw that the Cortex was not competition legal. So this doesn't mean that you can't use it in the classroom. It's just that at some point we want to make sure for the fairness of the competition that everyone is using the same equipment. And it also helps us run the competition more effectively because you've got all the same versions of firmware and equipment so that there's no user issues. So thank you for that question. We don't have an answer for when the Gen 1 equipment for the VEX IQ will be eventually phased out, but looking at past examples, it's definitely a lot of years before we start to see that no one is actually using the first generation equipment or previous generation equipment. Any other questions? Thank you.
Thank you very much. If there are no further questions, we will be sharing the video and a lot of like useful links we shared with you today in the presentation after the session. Yeah. Thank you very much again for your time today. Have a great evening, everyone. Yep. Thank you very much.
Thank you so much.